ਕਹਿਨੀ ਆ ਮੇਰੇ ਪਿਆਰ ਤੇ ਵੀ ਹੱਸ ਪੈਨੀ ਆ।
As you can see in front of us, we've got a valve. This is actually a globe valve. I'll just give it a little spin. And what we're going to do is work through the exterior of the valve first, and I'll explain to you the main components of the valve, and then we'll take a cross section of the valve and I'll show you some of the internal components. So let's start at the top. At the top of the valve we have what's called a actuator. Now an actuator, it may be pneumatic or hydraulic, or it may be manually operated or perhaps even electrically operated, such as with a motor. But the actuator is essentially opening or closing the valve, or moving it to a position between opening or closing, which is known as throttling. As we can see here, this is a hand operated valve. It's the hand wheel. If we zoom in, we can see some labelling. On the right we have close, and on the left we have open. This means that if we turn the valve to the right, we will put it into the closed position and stop the medium flowing through the valve. This may be a liquid or a fluid or perhaps a gas. Or we can turn it to the left, which is to open the valve, and again we will then have a medium that flows through the valve. The setup for valves is always the same. It's always righty-tighty, lefty-loosey. Try and remember that, otherwise you're going to put the valve into the wrong position. Now let's zoom out and we can see the actuator. It's being turned to the left, the valve is now open, and the stem, which is this spindle or long screw shape, has now come out the top. This is known as a rising valve because we can see that the stem has risen out of the valve. And if we go back the other way, the valve is now being closed, it's being turned to the right, the hand wheel, and the stem has gone back into the valve. So it's a rising type valve. Zoom out. You can see that the stem comes down, and you can see it here continuing down into the main valve body. And at this point here we actually enter the sealing arrangement, or part of the sealing arrangement for the valve. So there's always going to be some sort of a sealing arrangement to stop the fluid or the gas passing between the valve and the stem and leaking outwards. So that is this sealing arrangement that we're looking at now, and we're going to take a cross section of that later. So let's just zoom out a bit more. You can see another area of interest here. This is referred to as the bonnet. The bonnet is held on by these array of nuts going around the entire top of the valve, and the bonnet is designed so that we can open the valve and access the internals. The internal components are actually referred to as trim, so we're going to access the trim. Almost all valves will have some form of bonnet because it is essential to be able to get in there and maintain the valve. However, there are exceptions to this. Some valves are not maintained in this manner, especially some of the smaller valves that have a lower monetary value. In other words, it doesn't make sense to repair them or maintain them. It's a lot easier and quicker just to replace them. Let's go down a bit further. We can see we've got a connection on the end. This connection with all the holes, these holes are actually for passing bolts through, and then we will use a bolt and nut arrangement to tighten the flange. That is, if we look from the side here, this whole section, that's referred to as a flange, and each end has a flange. We can see another flange here, and the flange enables us to connect to the piping and support the valve between the piping. Typically we're going to use nuts and bolts, although it is possible also to weld the flanges to the pipework. Obviously, once you've welded the valve to the pipework, it's a lot more difficult to remove than if you've used a nut and bolt arrangement. But you'll generally only use this welding type arrangement when the medium flowing through the valve is particularly hazardous. Now each of the flanges also has a sealing arrangement. This allows us to seal the valve to the pipework, and if we can see here, this sealing arrangement is the black highlighted area we're looking at now. It has a ridged profile. This helps it to seal, and typically we use a paper gasket or maybe a nitrile rubber gasket, and that will help us to seal the valve to the pipework when we clamp the nuts and bolts together. The main reason for the gasket is simply that if we try to clamp two metal surfaces together, there would be some sort of leakage. And this is because when you press two metal surfaces together, they're both quite hard. So when you press them together, they don't seal very well. There's always some sort of a gap between them unless you use a very soft metal. So what we'll do, we'll use some sort of rubber or paper gasket and we'll squeeze that between the two metal surfaces, and this will then form our seal. We can see the inlet and discharge holes. Not sure which is which. I have to have a look around the valve. You can see here on the side that there is actually a flow indicator. That is this arrow here. So the flow is coming from the left and going to the right. That means that on the left hand side we have the suction or the inlet, and on the right hand side we have the discharge or the outlet. Between the two flanges is actually the body of the valve. That is the entire area between the two flanges. Sometimes people will also include the flanges as part of the body, and the body houses the internals of the valve, referred to as trim. So let's now take a cross section so we can look at the internal components. Okay, so there we are. Now we can see some of the internal components, and as you can see we've also added some labels. So let's do the same again. Let's start at the top. We can see our hand wheel as it's labelled there, or handle wheel as it's been labelled, and we've got a yoke sleeve that allows us to lower and raise the stem. That is effectively our anchor point. And without it, we would just be spinning the valve right or left and we would not have any vertical movement. So the yoke sleeve allows us to draw the stem up or lower it down. That is essentially its main function. If we look off to the right now, we can see the label for the stem. We can see something else which refers to as a gland bush. And the gland bush is used to press down onto what we refer to as the gland packing, and the gland bush will press down onto the packing and that will give us a seal. Now gland packing has come a long way in the past 100 years. Traditionally they would have used something like horsehair and they would have wound it together and then they would have inserted that in the area we're looking at now where this gland packing is. That's the black 3 stripes area we're seeing. And this sort of wound horsehair would have been stuffed in there and we would have used the gland bush to press down onto this horsehair and squeeze it between the valve bonnet and the valve stem. And that essentially then forms our seal and prevents any liquid or gas or whatever the flow medium is from leaking out of the valve. Now obviously we've come a long way since using horsehair. We now often use plastics or Teflon, and it is a lot more durable than horsehair. I should also mention that the horsehair would usually have been soaked in some sort of fat or oil to make it a little bit more durable and to allow the stem to turn more easily. The way this sealing arrangement actually works is if we go up to the top here, we can see on the left hand side of the screen now we have a nut and stud arrangement. A stud is essentially a bolt but without a head. So we can see that the stud has gone through the entire piece here and it has 2 nuts on the end. So zoom in, there is one nut and there is the other nut. So we're not using a nut and bolt arrangement, we're using what's called a stud and nuts arrangement. And we're going to clamp these 2 nuts down and we're going to do the same on the other side. I'll just switch back so you can see it. And when we tighten these down, we're essentially going to push this metal plate, the top metal plate, down, and that is then going to push the gland bushing down, this section I'm wiggling about here. As the gland bushing gets pushed down, it's going to compress the packing, and as it compresses the packing, it is going to seal the space between the stem and the valve bonnet, and that is how we get our seal.